Welcome to the GOTA virtual conference. Scan the QR code on the left to participate in our silent auction. The silent auction will run from October 1st to October 29th of 2020. Scan the QR code on the right to go to the GOTA online store. Thank you to our 2020 sponsors. Platinum level sponsor, the Shepherd Center. Gold level sponsors, All About Kids Therapy Services in the University of St. Augustine. And silver level sponsor, Hanger Clinic.
Essential Therapy Services is a pediatric therapy practice located in North Georgia. We provide quality occupational, physical, and speech therapy services to children ages 0 to 21 years. Our collaborative team of therapists work with children and families in the clinic, home, and natural environments to facilitate success and independence for children in all environments. We have locations conveniently located just off of Highway 400 in Cumming, Georgia, and just off of Highway 365 in Lula, Georgia.
This evening. Their session is entitled Haptic Strategies During Fine Motor Manipulation, a Pilot Study. So, as I said, my distinct pleasure to introduce Dr. Deena Shabat, who received her doctorate of occupational therapy from Nova Southeastern University in 2019, prior to moving to Atlanta, Georgia. She's currently working at an outpatient private practice pediatric clinic. Deena has continued to add to her specialties and passions through courses in DIR floor time, pediatric complex feeding issues, and is currently enrolled in Course 1 as part of the University of Southern California Sensory Integration Continuing Education Program. She'll be speaking tonight with Dr. Gustavo Reinoso, who graduated as an occupational therapist in Argentina and completed his PhD at Nova Southeastern University. He has been a clinician for 20 plus years, assessing and treating children and youth with disabilities in a variety of government, clinical, school, private practice, and community settings in the US and abroad. He is an instructor in the International Certification of Sensory Integration through the University of Southern California. Thus, he regularly delivers continuing education services, to clinicians and families in Europe, North America, Asia, Latin America, and the Caribbean. He has authored 2 new assessments, the SOCM and the COPR. And I think I'm going to upload this in the chat box so that people can get a look at that. Dr. Reinoso has published many peer-reviewed articles, books, chapters, letters to the editor, and training manuals. He is an associate professor in the Department of Occupational Therapy at Nova Southeastern University in Tampa, Florida. So with that, it is my great pleasure to welcome you all tonight, and let's begin your session. Thank you.
Thank you for having us.
Thank you.
We're really happy to be here. And let me see if I can share my screen. Can you guys see my screen?
Yes.
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 Okay, great. So I'm Gustavo, and I am going to be presenting with Deena. So our topic today is haptic strategies during fine motor manipulation, and it's just a pilot study, but we got some very interesting results, so we wanted to share this with you. Research on haptic strategies, particularly in children, we don't have much research. So an haptic strategy is basically the ability to identify objects and their properties, such as shape or size, texture, through manual or in-hand manipulation without using vision. So you see this in the neurological literature as stereognosis, but the main thing is just identifying properties of objects, without using your vision. So it is assumed that you're actively exploring the object, of course. And when you're actively exploring an object with your hands, that's kind of like the first stage of processing sensory information. So the movement and the information that you receive from that movement actually are integrating and in your brain. And there's kind of like two areas, you know, one is kind of like temporal, and another one is like localization. And that our brain does a lot of judgments about specific tasks based on those properties from different objects. So, always moving. So we know a lot about haptic strategies, and I'm sure if you're familiar with sensory processing, the work of Dr. Giner's, and many other researchers, you know, in the world have looked at tactile discrimination, praxis ability, motor planning abilities in the upper extremity for the most part, and in, you know, the whole body. But the idea is that when we recognize objects, it's not just the recognition of the objects, it helps with other functions of the brain, such as being aware of sounds and, you know, development of perceptual skills. But there's not a lot of studies that like link, you know, these two areas of research at the same time. So we have a lot of information in adults, more than anything in adults, usually because adults have lesions or injuries. So we learn from what happened to them when they have injuries, and then some issues with processing, not that many. And then we have a lot of hypotheses for children that have sensory processing problems in terms of tactile discrimination, manual perception. But again, there's not a lot. We need to do more research. So the idea is that when you explore objects with your hands, we know that you use at the very early stages your vision. You actually guide your hand with your vision. But, you know, the more you evolve, you know, and grow and develop, you start using tactile and proprioceptive cues, and you kind of monitor things with your vision, but you don't have to necessarily. So one of the things that happens.
So mom's got a new.
One of the things that happens is that sometimes we know, you know, some information about tactile qualities or tactile discrimination abilities in children, or we have some information about proprioceptive processing abilities in children, but we don't have a lot of things that test them together. So usually you have, you know, test of recognition of shapes or recognition of textures or recognitions of, you know, different properties. And sometimes they get mixed when you test them because it's hard to kind of like separate them, because when you move your fingers, you get proprioceptive feedbacks. When you touch an object, you have tactile input, but also proprioceptive because you start moving your hand. So those things kind of like work together, and it's very hard to isolate them. So, and yet we have tried for many years to test them separately. So we thought that it would be a, you know, a great idea to start playing with a protocol to investigate what are the haptic strategies during fine motor manipulation. So I have some experience developing some assessment instrument. This is an assessment that is coming out soon. There are structured clinical observations, motor, and comes with another test also to look at proprioception skills. And I work with Dr. Erna Blanche and Dr. Blanche Kiefer from the University of Southern California. And, you know, again, we have a lot of information about different systems, how different systems work together, but haptic strategies is something that we have not looked at very carefully. So when I was like looking at this, I was like, oh, you know, it'd be very interesting to do this. So I started thinking about this, like, you know, we need textures, but I don't want just the child moving the hand flat on top of a texture, because that would be texture recognition. So, but how do you do it if you don't, you know, don't have a texture? So the idea, you know, one day I was thinking, I was like, we should have cubes. We should not only see if the child can recognize what he or she's touching, but we also need to see how they manipulate. Because we have a group of kids that can identify textures, or they can move their hands. But the idea is, can they move their hands and recognize objects at the same time? So I, you know, embark in a research project, and you can't ever do research alone. So I was desperately looking for something and someone, and, you know, I got some support from the university, and they said, you know, you need a doctoral student. And I said, okay, well, give me a brilliant one. And I was very lucky. They gave me Dr. Shabat. She was my student, and it was one of the best students I ever had. So I was like very happy to have a residency. You know, she had a residency with me. So this is part of her doctoral project. And Dr. Shabat, it's all yours.
Well, thank you so much, Dr. Reinoso. So as Dr. Reinoso was saying, we initially had one cube that had 6 textures on each side. And what we did was we tested this cube with adults to see how are they using their haptic strategies. We wanted to identify any kind of model issues, textural challenges, as well as look at their haptic strategies. As Dr. Reinoso mentioned, there's a ton of literature out there that looks at how adults are using their hands for in-hand manipulation and the strategies they used, but not many on children. So we took what we found with those adults based on our coding, and we decided that because adults were using pinpoints or corners rather than identifying the entire texture, we minimized the cubes. So we created 10 cubes that had one texture on each side. So this basically narrowed in the texture specifically, so we were able to better identify how children are moving their hands while looking at the texture. How are they looking for this texture? So there were 10 blocks that had one texture on each, and then we also created 2 cubes that were used as distractors, and those 2 cubes had 5 textures on each side that were used for a different portion of our protocol. So the first thing we did is we created an artifact. We wanted to make sure that we were testing both vision occluded, and we had to figure out a way, how do we occlude a child's vision? And if you're familiar with the SIPT, there's this banner, this sheet that the therapist holds while administering the test. And we were like, well, there needs to be some other way to make it easier on the therapist as well as the child. So we created this box where on one side, the child will put their hands through, and on the other side, it's completely open for the therapist to make sure that everything is going according to plan. And we decided to use a Lycra fabric because based on our research, and we know that Lycra is the least adverse texture there is out there. So if the child does exhibit any kind of tactile defensiveness, that this would be an okay fabric to use. So what we did is the child would sit on one end and the therapist on the other hand. On the other end, the child would place their hands through the Lycra into the box. There was a slit at the top for a camera to be placed, and we would record all of our sessions. So as described, this is our setup. We had our 10 cubes in front of us with our 2 distractors. We had visual strips for our visual tactile portion. We had our camera that was used for all of our coding sessions, as well as our protocol, and then the child would sit opposite of the therapist. So this is our procedure. This is an example of how the child and the therapist would sit opposite of one another. So the therapist's hands are free, the child's hands are in the box, and you can see everything and observe without really needing to get involved in the child's space. In the visual tactile administration, per our protocol, the child will be given 1 cube as well as 1 sheet, and the therapist just asks the child, which number do you feel, 1, 2, 3, or 4? And the child just gives you a number. So rather than saying the shape, they feel with their hands, and based on the protocol, you mark 1, 2, or 3. We'll get to that in a second. But you're also marking if they scored correct or incorrect based on the number that they tell you. Is what they're feeling part of the visual tactile administration. In the tactile administration, you give them 1 cube that has 1 shape on top. And you administer this first for a couple of minutes, maybe 30 seconds to a minute, and then you give them a distractor cube. And the distractor cube also is paired with 1 shape. So if I gave 1 cube that has a tree shape, I would give them the matching distractor cube that also has a tree shape on the cube, but not right side up. So they would have to try to feel for that tree shape and match the 2 blocks together. This portion does not have any visual component with it. There's no visual strip. So this one is relying on their tactile sensory input. This is our scoring. So our visual tactile administration, it varied in difficulty. So we wanted to make sure that we weren't giving all easy, then all medium, and then all hard items. We varied difficulty based on our research with the adults. So we would give all 10 going on a scale of 0 to 1. 0 is an incorrect response, 1 is a correct response. We would give the child about 2 minutes to feel the stimuli. If for whatever reason the participant was struggling or having any kind of issues, we would switch out the stimuli to the next shape. We would count that as an incorrect response. After 2 unsuccessful trials, we would move on. We would discontinue that section and move on to the next section. The tactile portion was scored the same way. This one was more directed with easy stimuli, medium stimuli, than hard stimuli, graded the same way. 0 an incorrect response, 1 an incorrect response, and after 2 unsuccessful trials, the test at that point was discontinued.
So this is an example of a typical child. And I just wanted to just observe how it goes. So again, we're not just looking at how the child is able to identify the shape. We're also looking at the strategy that he or she is using to explore, sense, and discriminate that pattern in the cube. Just gonna move it a little bit so you can see. And it's great that we have a really good quality video, because then you can go back and look at what you did and score whatever you need to score.
So this was participant 19. He's a 9-year-old male, 11 months. We muted the audio, but you can hear him in the visual tactile portion telling us the numbers 1, 2, or 3. And on the visual tactile portion, he did extremely well. He identified 9 out of the 10 stimuli correctly. On the tactile portion, he only identified 1 of the 10 stimuli correctly. And I wrote here that he paired the cross with the sun, he paired a diamond lattice with the butterfly, and he paired the sun with the cross again. And at this point, the test was discontinued.
This is another child. And hopefully you can see the difference.
This was participant 17. She's a 5-year-old female, 3 months. On the visual tactile portion, our forced portion, she actually identified 0 of 10 stimuli, as compared to the tactile portion, which is a little bit harder. She actually identified 2 of the 10 stimuli correctly. So we decided to create these parameters to grade how the children were searching for their their stimuli. So we created patterns utilized to interpret the child, and we found that the child rarely sticks to one strategy. Based on our research, we found that adults don't stick to one strategy. They vary up the strategy based on the tactile stimuli that is presented. So we developed and ranked haptic strategies based on complexity, starting from a simple strategy to a more complex strategy. Each item is a standalone item and it doesn't rely on the other one. And we created them based on inter-rater reliability to find consistency and unison between each grader who's grading haptic strategies. There are 4 items out of 15 that are inversely graded. So the highest possible score on this haptic strategy construct was a 15. We found that the higher the score, the more complex the haptic strategy was. So these were our haptic strategies.
Yeah, we give you a second so you can look at them, but they go from very simple to very complicated.
So you see the first one says whole hand patting. And then further down the line, it says there are 2 hands in active exploration. So we start with a very simple search strategy, and then we go into a more complex strategy.
So one of the things that we needed to do when we have this is, analyze the data. So we rely on a statistical model that is called rash analysis. And the idea is that you try to assess if that construct that you have with those items, it is really a construct. And if the children that you have really fit a pattern, and if the items that you have also fit a pattern. They kind of like form a shape that you have right here. And the idea is that a child that has very low ability, which is like kind of like right here, -3, -4, should have a very low probability of, answering or, picking the right shape or texture. And a child that has a positive number, like let's say 3 or 4, will have a very high probability of answering the item correctly. So it's really a mathematical model used when you have data that is not really ratio or interval. So what you're trying to do is like you're trying to convert the scores that you have in something that is like more mathematically correct to do, computations. So the idea is that you have a trait or a construct and you want to make sure that it's kind of like tight and you're measuring one thing and not different things. So you want to measure that these items really are kind of like hanging together and they're measuring haptic strategies. We use there's different software. We use WinSteps. There's other software, but this is one that I know really well, so I use that. And you get these very complicated tables that I don't want to bore you with, but I'm just going to show you some kind of like basic things. So one of the things that you look at first is like the correlation among different items. And usually here you want like numbers are like 0.3. 0.3 is a really good number. And if you see they're like pretty high numbers, so that means that those items, they correlate together, so they kind of stick together. You also have something that's called outfit, just to see if like, persons or items are not really fitting that model. And the model that I showed you before, that people of low ability will have a very low probability of answering correctly, and people of high ability will have a high probability of answering correctly. This is kind of like a probabilistic model. It's like different from the more classic statistics that use the bell-shaped curve. So we use kind of like that ogive kind of shape. Those are the name of the items, so they're kind of coded. And those are logits, and logits is kind of like the unit of measure for rash analysis. So they go from very negative numbers to positive numbers. And the idea is that those are very evenly distributed along the construct or the trait that you're measuring. So if you remember, they're basically on the x-axis here. So you have, for example, if you have a person that have like a 2.7 logit, that person will have a very high probability of answering the item correctly. There's a lot of literature about how you need to look at these numbers, and do a lot of rationality, so I'm obsessed with these things. But the idea is that it looks very mathematical, but really it looks a lot like a qualitative research project. What you do is like you look at your numbers to see if there's some things that are not behaving the way you want them to. So for example, you have a person of low ability that answers, correctly a very complicated item. So that, you look at that person as that person is not behaving in a way that is consistent with the model, which is what happens when you have, for example, sensory questionnaires and you give them to the parents and the parents answer always, 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 even to items that are opposite. So this model doesn't let you do that. It helps you to identify patterns of responses that are really atypical. So when you identify an item or a person that doesn't behave according to the model, you explore why, and you potentially eliminate that person because that person doesn't represent the construct really well, because either it wasn't paying attention or it was just an atypical response. So you go through this process several times. It's called calibration. So you have different calibrations. So you try the model with different items, different people, and that's why you have to have large sample sizes. And we don't, this is a pilot study, but we have enough that allow us to see people of low ability, people of medium ability, and people of high ability. So we started with more items that we ended up with because that's the process that you need to go through. So if you see there's a table here, and then you end up with less items to the right. We have very good numbers for both items and persons. So the first table is items and the second one is children. So reliability is like 0.86, 0.87, 0.83, 0.84. So it's a very stable measure. So we were very happy with these numbers. We also create, this is called a right map. It's kind of like a model for rationalisis. And you have kind of like the mean somewhere in there where that dot is. And to the left, you have the children, and to the right, you have the items. So if you take a look at it, we have children that score very low, closer to the mean, and really higher than the mean. And we also have items that are able to capture children at a very low level, medium level, and very high level. So you really want to have something similar to this distribution, because that means that the measure behaves the way you want it to behave. This is similar to factor analysis, if you're familiar with research, and the idea of factor analysis in RASH analysis is called a PCA. So the idea is that you try to see if the residuals of your measures kind of like, again, go together to see if there is a second dimension. And here it didn't do so well. It seems like we have, you're supposed to look at this square right here and see most of the uppercase letters. So they all should fall somewhere in here. And then most of the lowercase letters should fall here. So we have a couple of items that don't really go together, but they're not that bad. So it's still pretty acceptable. And the nice thing with this is that we also have you end up producing a table where you can actually look at data in a very specific way. So for example, you have someone with a score of 5, if you look at right here, and that person belongs to the 5th percentile, in comparison to someone that scores 29 that belongs to 84th percentile. And you need to look at those numbers. That's the logit number that I mentioned before. So that person is like minus point, it's almost 4 logits, on the ability scale. And that's why it scores very low. And then you have a positive number on the ability scale, and that's why that person scores on the percentile. So you almost like you have the first person is like right here, very low ability level with a very low probability of answering the item correctly. And then you have someone with a higher ability level with a very high probability of answering the item correctly. So what is really nice about this is that these scales are equal intervals, which means that you can throw in here any child of any age, and it would basically create a score, and it would place them along this scale. So you can keep studying children and of different types of abilities, different diagnoses, different ages, different ethnic backgrounds, and their output keeps generating different lodges and puts them in these scales. You can really have or study very different, diverse samples and get a very, very refined calibration of what is the ability level of the child and what is the probability that the child will be successful or not successful in answering those items correctly. So some conclusions and implications for practice.
So after all of our wonderful rationalisis that we did, thank you, Dr. Reinoso, we basically eliminated a couple of our qualitative parameters that we did to judge our haptic strategies, and we eliminated actually a handful of items from both the visual, tactile, and tactile portions. And what you see left are what we found was the best fit and best tested the tactile and visual discrimination abilities of children. So on the left, you have your qualitative parameters, and on your right, you have the visual tactile items and the tactile items that were the best fit for our model.
And this is really interesting because it allows you to eliminate items that are really not great. If you remember the map, where you have the items on the map, if you have items at the same level, they're measuring kind of like the same thing. So you can actually eliminate, items. And I was a clinician for a very long time, and I really respect assessment, but sometimes assessments are too long and you can't keep the attention and the organizational behavior of the children to, complete your items. So with this assessment, you potentially have 4 items for visual tactile and 5 items for tactile. And the parameters that you are observing when the child is displaying those haptic strategies, they go from very simple to very complex, and they're dichotomous answers. So you just basically have to circle yes and no. So we think that there's potential not only for discriminating from children of low and high ability, but also to do it very quickly, because you can discontinue the administration very quickly, and you only have 9 items. So that's very exciting.
So literature suggests that deficits in haptic perception may result from impairments within the somatosensory processing with visual perception, cognition, and manual and hand manipulation skills. We see that this is also, the somatosensory processing is mainly for our spatial orientation as well as stereognosis. Our study aimed to assess the processes that children engage in identifying the object, which allowed us to really look at the quality of in-hand manipulation, look at the strategies, the haptic strategies that children used, as well as identify correct and incorrect. So not only did we look at the product, so right or not right, we also looked at the process that children were taking. So we really looked at what strategies are children using, how can we relate that to the adults, the literature that we're looking at in adults. And we find that based on our qualitative parameters, we can see the developmental of haptic strategies and link them to an appropriate development to what is written with adults.
So the main idea for us is that many times some of the assessments that we have, for children is like, something is correct or incorrect. And we have that when you look at visual, tactile, and tactile, you can say, correct or incorrect, but the parameters allow you to say, this is how the child is going about solving this particular item. So you're looking at the quality or the haptic strategy that the child is using. And it allows you to place them in a very fine line of discrimination from very low ability to very high ability. Again, we have a lot of theoretical information that relates difficulties in tactile discrimination with motor planning. We have a lot of information that, relates general motor planning with gross motor skills, with fine motor skills, general motor planning with ADLs, but we don't have a lot of empirical evidence. So we believe that if we continue to study this, you can capture, okay, is the child discriminating tactile information by getting the items right, but how are the parameters? So if the parameters are low, indicating poor discrimination of tactile and proprioceptive information, you can link perhaps that to other activities such as handwriting, dressing, etc., but doing it in an assessment that will probably take you between maybe 10 minutes if you're quick, now that we have a way of just looking at very specific items. So again, the idea would be by using cube 1, 4, 7, and 5 for visual tactile. This is the one that the child would feel the cube and name the texture, or just basically the number that corresponds to the texture. And then the tactile by identifying one block with one hand and matching it with the other hand, and you only have 5 for those. The discontinuation rules are very fast, so you can, very quickly go with part 1 and part 2, and then you have to code these parameters based on how the child moves his or her hands. We don't believe that you have to video record it, although if you video record it, you probably can look at it, at a later time with a little bit more detail. But we also know that clinicians don't have the time to do that. But if you have a big opening in the box, you can just look at the strategy. And because these items are ordered, and that's something that is really important. 99% of the assessments that we have, they have items that go from simple to complex, but that is a theoretical concept. It's not an empirical concept. This is like an empirical concept. This item, the client engages in whole hand padding, is in the same scale as the client has difficulty remaining in their seat, or the client explores the entire texture. So this is kind of like a ruler, and the distance from each item is the same. So if you, for the most part, will be like, let's say that you have a very high ability child, no, 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 and then you move yes, 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 yes. If you have a child of very low ability, it will be mostly no. And if you have a child of mixed ability, or a child that is behaving inconsistent with that pattern, you will probably have to look at the organization of behavior. Is the child nervous? Is he anxious? Is he not following directions, etc. So we have high hopes for perhaps continuing to researching this and see how we can make it better. And that's all we have for you guys. And we wanted to just have enough time for you guys to ask any questions that you may have. And thank you for sitting at this late time at night that I know is super hard.
That is so fascinating. I mean, just the descriptors of the strategies alone. I mean, you guys know how hard it is to write a note. And I'm just looking at this going, oh my gosh, you've given language, operationalize those movements. So, I mean, I don't want to hog up all the questions, but I just had to tell you, and your points about anybody who's done a TVPS or something where the child's going, number four, number four, number four, they just want to get out of there is a...
This one.
Yeah. Anything from the floor? Because I could keep talking, but I don't want to.
And again, we don't mind any questions. So any questions, they're all good.
What kind of camera did you use?
We try everything first.
It was a GoPro, actually. I think it was a GoPro.
It was a GoPro. Yeah. We use an iPhone first, then we use a flip, then we use a GoPro, and we keep trying different things. And because you have to have like some light inside it, otherwise the video is poor quality.
Right.
You're seeing it, but then you also want to get it recorded, because it's not, sometimes what you see, it's different than if you see it again.
Yeah.
So it ended up being a GoPro, yes.
Yeah, I thought it was just fascinating, the videos without the sound. I mean, because you see that, I mean, that padding and then the fingers, I was just glued to that. My goodness. And there's something in the chat. Hi, Becky. Oh, okay. I will, at the very end, we'll remind everybody to get their CE. Any other questions? I definitely liked all the explanation of again, the rationales. I mean, if you've done an AMPS or a PD, that model is great, especially the words infit, outfit, misfit. I'm like, okay, I can understand that.
Yeah, there's a tradition in the US of using classic testing theory, and it's not the best, but we're moving very slowly to rationality. So we have some assessments like the PD, the school function assessment, the goal use also rationalities, the SPM, sensory processing measure. They validated only one portion with the rationality. So it's kind of like, getting better and better. But I think the most interesting concept about that analysis is that you can get a very, very, a nice ruler. So when you have a behaviors move in very nice order. So when you look at those parameters, like Dr. Shabat was saying, you can really see that children, maybe they get the first, get the second, and then you start seeing like, okay, 0, 0, 0, 0, 0. So you're not going to see like 0, 1, 0, 1, 0, 1. It's kind of like very nicely ordered. And that I think would help the clinicians to make a quick note when they have to do documentation as well, hopefully.
This is an odd question, but I have a friend who is very knowledgeable with primates, particularly capuchin monkeys, and has used some of information I've shared with her from OT about the prehension patterns of the capuchin monkey. And I was just wondering if any of that research comes back this way towards you all. Do you all review any of the the primate research on hand function?
I don't think we run into any of those articles. I mean, some of the functions of the primate hands, they're known, but no, we didn't run into any of those. They usually know them at the motor level. They know a little bit less about the sensory level. But no, we didn't look at any of those.
So what are next steps with this research? What are you doing now with it?
Let me tell you that Georgia stole Dr. Shabat from us, okay? She decided for Georgia, which you guys have a beautiful state, so I don't blame her. But research takes time. It's kind of like a slow cooking project. So developing an assessment takes years and years and years of refinement. So hopefully at some point we will, look at different samples, increase sample size, look at
expand.
Okay.
Yeah, you need to look again at the blocks. Do we want them small? Do we want them bigger? So it's a long process.
But is that in the works? Is what I was asking?
We're thinking about it.
Well, good. Because you see the signs in early intervention. Y'all know that, And I was going to ask you too about your sample. What was that age range again? And
we had 31 people.
Okay.
15 females, 16 males between the ages of 5 and 10.
5 and 10. Okay. All right.
And it's interesting that if you look at ages, it really didn't go along ages. So you have very good, Haptic strategies at a very young age, and you can be very bad and older. And they're all, they're typical, So I think that if you now move that to, individuals with disabilities, you would have also a very different distribution. So I think that the items will be very discriminating. So it will be interesting, for example, to see in early intervention, if you get the kids to, put their hands and see what they do.
Right.
How do they try to explore the blocks? That would give a lot of indication for predictive value for how motor is going to evolve. Yeah.
That was so fascinating because we can all do the hands. I mean, that we see. Gosh, I was going to ask you something else about that. Becky, do you have something else? Because I was going to. I don't know what it is right now. Just popped right in my head, but I really love those videos. Anyway, I don't know. Like you said, the time of the night, I guess.
Yeah.
Anyone else out there?
I just think it's wonderful research, and I think the information is gonna really help long term. And there's a need for more sensory processing information to confirm what we see, what we know.
And what I liked about it, you said, Gustavo, you did say it seemed more qualitative, but I mean that fingertip, that in-hand manipulation, I mean, just operationalizing those haptic strategies goes a long way. And for the quality of research there too on this very, very, this is what I was going to say. When y'all were talking, now we have these COVID procedures that we do now. We're picking up the kids curbside. They're washing their hands before therapy. They're washing their hands between therapies. I'm really watching. It's very interesting how all this hand washing that they're doing and that they're doing it by themselves. It's a good thing because where a therapist may just automatically go into session without having the children do a lot of that. But now that we're doing it, like one kid could possibly wash their hands 6 times if they're going from OTPT to speech or something like that, before and after each session. But all that practice is really good for the kids, is what I've seen, and how they're picking up a lot of more movement strategies with manipulatives. So fascinating that way. I was thinking about that. As y'all were talking, I was like, yeah, maybe all this hand washing is a good thing because they have to get the towel, open the faucet, get the soap, and then 30 seconds washing. So really good. really good. Okay, out there, we are at a good place. Any further comment from you guys, or anything you want to?
No, I just, again, it takes a village. I was very happy to have Dr. Shabat for an entire semester. So I think that, that you were talking about the qualitative parameters, and they got reviewed like 17 times.
A lot. We went through a lot of trials of inter-rater reliability on those parameters. So,
Well, you have the numbers. I mean, that does your, those analyses and that calibration and the models you use are, I mean, that's solid. So,
and I think that that's the way that, that we need to look at the future, like, partnership between, students and clinicians and universities to kind of like, put, some kind of programs, some projects that are not just useful for our intellects, but something that we can use in a clinical setting. That is not something that takes 2 hours of 500, pounds. Something quick, and because that's how it is in clinical practice. So just to encourage all of you guys to work together, because I think that when we put together clinics, students and people from universities that have like the knowledge for IRBs and all those protocols.
Right. Well, does that mean that we can? Does that mean that we can contact you, or you'll be contacting us? We have 3 universities here, and that would be really good, because the practicality of it too. I mean, quick 10 minutes. I mean, that's
what we need.
Very useful.
That's what we need. Yeah, that's what we need. I think sometimes we go to clinicians with these things that are like 2 hours, and they're like, we don't have this time. So I think that we need to be cognizant of what what clinicians are doing on a regular basis, so then we can create things that are helpful to identify and document what they're doing every day. Okay,
that's very, very true. Okay, well, we're going to be looking for more information from you on this, but let us know, because we've got the students. Thank you all so much. Can everybody come on, if you don't mind, on your videos, because I'm doing this where I take a picture of who's on, and we would like to just thank you for this wonderful, very, like I said, very well done project.
Thank you.
Amy, I see you. There you are. Hi. Anybody else care to come on? Because I'm going to get my picture.
I'm working on it. Should be.
Oh, there you are, Kristen. Good. I'm recording all this, I'm documenting for posterity. Thank you guys so much. Y'all have, see? Thank you.
Hi, guys.
I knew I'd get everybody out. All right.
And don't forget to go online and finish the eval.
Okay.
For credit.
For your CE. And so we look forward to seeing you guys again, Deena and Gustavo.
Yes, thank you so much for having us.
Thank you so much for having us. We really appreciate it.
It was well done. Thank you. Good night, everyone.
Good
night. Bye, guys.